Hi, I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at how to construct a histogram using the iris dataset. As you all know, a histogram is a frequency distribution plot. A histogram is used to check the distribution of the variable. Now, there are two important things that a histogram conveys. First, the histogram tells you the shape of the distribution. Secondly, a histogram tells you the spread of the distribution. To construct this histogram, I'll be making use of the dataset iris. Now, the dataset iris is present in SAS help. Let me just type in the code for histogram. You have to just simply type proc sgplot data equals. You can drag and drop the dataset name here. Iris dataset is present in SAS help library. This is the first line of code. In the second line, I can type histogram. This is the command that I will be giving. The variable that I'm interested in is the variable petal length. So let me just drag and drop this variable petal length, put a semicolon here, and simply type run. I'll select this code and execute this code. Once you execute this code, you will be able to see a histogram. The x-axis corresponds to different range for petal length. For example, the first bar corresponds to 0 to 10. Those flowers which have a petal length from 0 to 10, 10 to 20, 20 to 30, 30 to 40, so on and so forth. And the y-axis shows the percentage of flowers which correspond to each of these petal length ranges, right? So that's how you interpret. You can also use a histogram to check whether the distribution follows normality. Remember, for a variable to follow normality, it should have a simple property, that is the mean equals median equals mode. If a variable has mean equals median equals mode, that is the mean median mode coincide, then you'll get a beautiful bell-shaped curve. And when the variable follows a bell-shaped curve, when a variable demonstrates a bell-shaped pattern, then you can conclude that the variable follows normal distribution. When I look at the distribution of the petal length variable, I can't see a bell-shaped curve. It does not follow a normal distribution. That is my conclusion when I look at the histogram. So this is how you can construct a histogram. There are certain other important properties of histogram. Let's say you have a categorical variable. I have a categorical variable called species, and I want to see the spread of petal length corresponding to each of the species of flower. So to do that, let me just copy this particular code, paste it in line number 8. Now, once I do this, there is an interesting property that I can give, and that is I can simply say group / group. This is the additional option that I'll be specifying. I can say species. So let me select this particular code and execute it. It's expecting an equal to. I think I've made a mistake, and that is group equals species. Let me execute this code. You see a wonderful petal length distribution here. This particular histogram is self-explanatory. As you can see here, there are three different colors that are being used to demonstrate, to convey three different species of flower. As you can see here, when it comes to setosa, the petal length does not exceed 20 millimeter. The petal length will always lie between 0 and 20 millimeter. Now, when I look at the second species of flower, that is versicolor, you can see the distribution here. It is moderately distributed when it comes to the petal length. And finally, when you look at virginica, the high petal length corresponds to virginica. It can sometimes even exceed 60. So the three different colors correspond to three different species of flower, one corresponding to setosa, and you can see here setosa flowers usually have a lower petal length, and when it comes to virginica, the petal length is on the higher side, and when it comes to versicolor, the petal length is moderately distributed. So this is how you can use the group by property. You can use the group statement. You can see here, you can use the group statement, and within the group statement, you can specify any categorical variable and compare the distribution of the different categories of petal length. Now, the third thing that you can do here is you can suppress the histogram and use a KDE, or a kernel density estimation. Let me just show you how to do a KDE plot. The first line of code will be as it is. I can just copy this piece of code as it is because I'm working on the same data set. Now, instead of having three different species of flower, I'll restrict my analysis only to two. And to do this, I can specify a where clause where species in, I'll have to open parentheses, and within parentheses, I'll have to name the two species of flower that I am interested in. The first one is setosa, and the second species that I'm interested in is versicolor. I presume there is no spelling mistake. So these are the two species of flower that I'm interested in. Instead of histogram, what I will do is I will give a new command that is density. Now, this is a very, very important command. Now, what KDE does is it shows the data using a continuous probability distribution curve, right? It is analogous to a histogram, but a KDE helps us depict the PDF, or the probability density function. I can use the density command, and here what I'll do is I will use the variable sepal length. I'm going to use sepal length slash type can be specified here. Type will be kernel. You have to specify type as kernel, and then what you can do is you can say group equals species. Group equals species. I can put a semicolon and run. Right, so this should produce a KDE plot, right? Let me just select this and execute this. It is giving me no error. Let me look at the results. Options, notes, no source. Okay, let me just go back to the code and see if I have just typed this properly. Let me use a semicolon here. Where species in setosa. Okay, let me just look at this data set. I've got variables setosa and versicolor. Let me change it to S, and let me make this as V, right? If you look at the word setosa, it's in caps S, and versicolor is in caps V. Let me go ahead and execute this, right? So this is the mistake that I had made, that SAS is case sensitive. So when I'm specifying the values of a variable, I need to be careful here. I need to respect the case in which the words appear, right? So let me look at the results here. Look at this. This gives me the distribution of the two species of flower. You see the blue line that corresponds to setosa, and the red line corresponds to versicolor. The spread is wider in the case of versicolor, which means that when it comes to the sepal length, the dispersion is higher for setosa flowers. On the other hand, when I look at the species setosa, that is the blue color KDE, the spread is not as wide as that of versicolor, which means that the spread is little, it is narrow, and when it comes to versicolor, the spread is wider. So we can conclude that higher the spread, more the dispersion, lesser the spread, lesser is the dispersion. So this is how you can use a KDE to check the dispersion of the curve. With this, I come to the end of today's presentation. In this presentation, we have seen how to construct a simple histogram. We have also seen how to construct a histogram and break it down by the different categories of a categorical variable. And the third thing that we have seen is using the density command. How can you construct a KDE plot? A KDE plot can be used to approximate a PDF, and we have constructed a KDE for the variable sepal length. We have compared the distribution for setosa and versicolor. With this, I come to the end of today's presentation. I thank you very much for watching this particular video. I request you to subscribe to my channel and hit the like button. Thank you very much.